Now we're going to look at a problem that deals with integration and vertical motion. If you recall, in previous videos we looked at an example where we had a position function s of t, and we said that we could take the derivative of the position function here and we could find the velocity, and we could take the derivative of the velocity function or the second derivative of the position function, and we would have the function for acceleration. Well, in this example, we're going to have to do the reverse. We're going to be given the acceleration and we need to find the velocity. And in order to do that, we will have to do the opposite of finding the derivative, so therefore we will have to integrate. So we can integrate the acceleration function to find velocity, and if we integrate the velocity function, we can therefore find the position function. So keep in mind that's what we're going to have to do for this given problem. This problem states that we have a ball is thrown vertically upward from a height of 6 feet with an initial velocity of 60 feet per second. How high will the ball go given the acceleration is a negative 32 feet per second as the acceleration due to gravity. So here, this negative 32 feet per second, that means every second we're accelerating 32 feet per second. And if you've never had physics before, this is a problem where the negative 32 here is your acceleration from gravity. So here we have the problem set up. We're 6 feet off the ground, and the initial velocity, which is v sub 0, is 60 feet per second. So we can start with the idea that we know our acceleration, a of t, is equal to this negative 32 feet per second squared, and you can think of this as negative 32 feet per second, or we can simply write per second squared. Now, in order to solve this problem, we need to find the function for velocity. Well, we can simply integrate to find velocity. So the velocity function is going to be equal to the integral of negative 32 dt, and we're using dt because we're integrating with respect to time t. So we can easily integrate here, and we would end up with the integral of negative 32 as a constant, so we would have a negative 32t plus our constant. And for this example, I'm going to call this plus c sub 1. Okay? Now, this is the general solution because we don't know the value of c, but given some of the information from the problem, can we find the value of this constant c sub 1? Well, if we look over here, we know the initial velocity is 60 feet per second. Okay, so there's your initial velocity, and that's going to occur when t is equal to 0. So when time t is equal to 0, before any time has passed, our initial velocity is 60 feet per second. So that's like saying when t is 0, our velocity is 60. And what do we know about the actual position? Well, the position at that time, we're 6 feet off the ground. All right, so now the velocity we said here is 60. So we can plug 60 in for v. Negative 32 times t, well, we said that's going to be at time 0. So then we can solve for c1. And in this particular case, because of the 0, everything cancels, so we're left with c sub 1 is equal to 60. So therefore, our velocity function would simply be negative 32t plus, instead of c1, we would have 60. So there's our velocity function. Okay, now is that going to help us yet? Well, the question is, how high will the ball go? So if we're looking at how high the ball is going to travel, that means we're looking at the position. So we're going to have to integrate one more time in order to find the position function. So if we integrate velocity, then we know that we're going to end up with our position function. So that means S of t is equal to the integral of negative 32t plus 60 dt. And let's see, there should be an equal sign here. There should be negative 32t. So then if we integrate this integral, it's pretty basic. So we would end up with a negative 32t squared divided by 2 plus 60t plus c sub 2. And if we simplify this, we have a negative 16t squared plus 60t plus c sub 2. And I'm calling this c sub 2 because most likely this is going to be a different constant than what we found over here for the velocity function. So now, do we have enough information to find the constant c2? Well, we need to know the time and we need to know position. Well, if we look over here, we have 6 feet. This here would be your initial position. So that means we would have, this is going to happen at t equals 0. So at t equals 0, the position would be 6. So if we substitute that in, we're going to end up with 6 equals negative 16 times 0 squared plus 60 times 0 plus c sub 2. And once again, we're fairly fortunate because the 0 causes everything to cancel, and we know that our constant is equal to 6. So therefore, our position function, S of t, we could write this as negative 16t squared plus 60t, and then in place of c2 we plug in our 6, and here we have our position function. So now, how can we determine how high the ball will go? Well, if we think about this in terms of velocity, the ball reaches its maximum height when? And that's going to happen when the velocity v of t equals 0. So if you think about that for a minute, if we throw this ball up, we know that the maximum height, the velocity has to be equal to 0 because it's going to stop before it starts to come back down. So therefore, when is the velocity equal to 0? Well, if we take our velocity function, which is negative 32t plus 60, negative 32t plus 60, we can set that equal to 0. And by doing so, we can find the exact time at which the ball reaches this maximum height. So therefore, we have t is equal to negative 60 divided by negative 32, which turns out to be 1.875 seconds. So then we know that at this time, at 1.875 seconds, the ball is going to reach its maximum height. So therefore, we can take this number and plug it into our position function and evaluate it at a time of 1.875. So you'd have a negative 16 times 1.875 squared plus 60 times 1.875 plus 6. And if we crunch the numbers here, you will find out it's going to be at a height of 62.25 feet. So we know it's going to take 1.875 seconds to reach this maximum height of 62.25 feet. So keep in mind when you have a problem of this type dealing with velocity or acceleration or the position, remember how we discussed before, if you take the derivative of position, you end up with velocity. The derivative of velocity gives you acceleration. So here we can always go backwards. If you're given acceleration, we can integrate to find velocity, and we can take the integral of that to find our position function. And you'll find that knowing this, these three functions, position, velocity, and acceleration, will be very helpful when solving these types of vertical motion problems.